Good afternoon, everyone, and welcome to the second day of the PhDCast, an event sponsored by University of Pisa. PhDCast consists in a series of interviews to important personalities from computer science and related fields.
Today we are pleased to interview Prof. Christopher KANAN from Rochester Institute of Technology, New York, who is going to talk about continual learning. Dr. Alberto Massida from Meta, London, a machine learning expert, and Dr. SOLÈNE NEYRET from Métiers, ParisTech, France, who performs neuroscience experiments in virtual reality environments. Also, with all of that, we talk about their experience as PhD students.
And as yesterday, we would like to thank the University of Pisa for sponsoring the event, and the guys from Pointer Podcast who helped us with the directing, and also the speakers who gladly joined our interviews.
And as yesterday, we remember that we work hard to organize this event, and again, we will hope that you will enjoy also this interview. So, enjoy.
Welcome everybody. Welcome to the second day of the PhD event 2021 here at the Department of Computer Science at the University of Pisa, of course. Today we have Professor Christopher KANAN here as our guest. I won't talk to you anything about him, but rather I would ask Professor KANAN if you could please give a brief introduction about yourself, your work, and your scientific interests.
Well, first, thank you so much for inviting me to present to all of you and to chat. It's my honor. So my name is Chris KANAN, and I'm a tenured professor at the Rochester Institute of Technology, where I run a lab working to overcome a lot of the current limitations in deep learning, especially to enable lifelong machine learning, and we can get into them more about that later. I'm also a visiting professor at Cornell Tech. It's an offshoot of Cornell, where I teach deep learning, and I'm also the director of AI science at a startup called Page, where with about 180 employees. So I oversee the AI R&D branch of the company, which is about 40 people. So I kind of like lead the scientific vision, if that makes sense. Where what Page works on is trying to improve the diagnosis and treatment of cancer patients which is AI empowered. And my primary academic interest, like I said, is related to lifelong machine learning. So I'm trying to make systems learn more efficiently over time, just as we do. And I take a lot of inspiration from neuroscience to do that.
Okay, so let's talk about your field of research, deep learning. And can you tell us when this interested in deep learning, but also, as far as we know, also continual lifelong learning started, and how did you choose to study this kind of field when you, for example, started your academic career?
You're in for a bit of a story. So my interest, to be honest, my interest in artificial intelligence began in the 1990s when I was in high school. So during high school, I had taught myself to code in a language called Quick Basic and then Visual Basic. And that's what I did. I was just obsessed. And then we got the internet in my town in around the 1996 maybe, and all my friends who had gotten it before me were all playing what was called a multi-user dungeon, or MUD, which is like a precursor to modern MMORPGs like World of Warcraft. So basically, it's a text-based game. You log in with like a telnet client, nowadays like SSH, I suppose, and all my friends were playing this, and I thought, well, I'll write my own telnet client. Obviously, this is something a normal person would do. And then I thought, well, now that I wrote this, they're all playing it, and I'm like, well, this is not. It's kind of boring. I'll create an AI, and I don't know. I have no idea what I'm doing. Right? There weren't search engines. Wikipedia didn't exist. There was so little like to actually find any information on this topic. So, but I just hammered away at it just by saying, okay, how do I make this agent in this text-based world? You can go like, go north, go west, go south, go east, go up, go down. Those are my like commands. Operate in this, interact in this world. And so to do that, I like ended up having to actually develop a crude form of like graph data structure. And I didn't know what they were called. I called them maps because I didn't have anything besides my intro to Quick Basic book and the Visual Basic 5.0 help files that Microsoft provided. That was the only things I had as my resources. And so I ended up creating basically breadth first search to get the thing to go around and creating a big expert system of like 20, 30,000 lines of code for how to do that for the behavior of the agent. Managed to get from level 1 to level 13 just by killing chipmunks and a bunch of other stuff. That's everybody knows those kinds of games. I doubt much has changed. But anyway, so then during undergraduate, that got me kind of like interested in this. So while I was at undergraduate, I got really interested in AI. And so I finally, in like my 3rd or 4th year of undergraduate, got to take the one intro to AI class. And they taught me the basics of kind of classical methods in artificial intelligence. And they had a couple lectures on neural networks. And I thought, well, neural networks, obviously, this seems like the right way to do this, but these obviously don't work. So why don't we study the brain? And I double majored in philosophy as an undergraduate. So I was really interested in philosophy of mind and philosophy of AI. And so I thought, well, obviously neuroscience, I don't know anything about it. I took a neuropsychology class too in undergraduate. I was like, this is the secret. So I went and did my master's degree at University of Southern California with a man named Michael Arbib, who was one of the founders of the field of theoretical neuroscience and computational neuroscience. And so I worked with him to try to figure this stuff out. That got me equipped with a lot more knowledge, but still neural networks didn't work very well. I mean, now I knew a bunch of neuroscience and neural networks still didn't work. But he got me this job at HRO Labs. I know, I'm sorry, this is a story. He got me this job at HRO Labs where he had a grant to work on brain-inspired vision with neural networks. So I got a job there. Still, these neural networks were super crude, like very, very, very crude compared to what we deal with today. In fact, they'd abandoned like the kind of, but while most of the approaches that we use today were developed in the 1980s, actually using other methods instead of like our conventional neural networks, like radial basis function kinds of neural networks. But anyway, so I got a job there working on these things. And while there, after I'd already finished my master's degree and was trying to get into PhD programs, a paper came out in Science from Jeff Hinton where he like introduced the first deep neural network. And I got super excited about it. At the time, I didn't fully have enough background to fully understand everything in that paper at the time. It's like used a wake-sleep algorithm with an autoencoder, and then they fine-tuned it afterwards. So supervised pre-training was the secret. But there was another paper adjacent to it by a man named Gary Cottrell entitled A New Life for Neural Networks, where he predicted that neural networks were now going to overtake everything, whereas they had basically been abandoned. Everybody abandoned them. So I brought this up in a meeting and I was told, please don't talk in meetings anymore. But then I went and did my PhD with Gary. And after I did my PhD with Gary, everybody said, don't work with him. Neural networks are dead. He's a neural networks guy. Don't work with him. Don't work with him. Don't work with him. But he introduced me to all the Jeff Hinton, Jan LeCun, all these people back in the day when nobody cared about them. And so, yeah, that's really what got me started. And since Gary was kind of a cognitive science and kind of like an old school connectionist, like he did his mentor was a man named David Rumelhart, the person who came up with backpropagation, like the algorithm we used to train neural networks. And so, he was just like, this is the secret. We got to do this stuff. Learn from the brain. We got to do this stuff. And everybody's like, my other people on my PhD committee were like, life mistake. Don't do this. The career will be dead if you work on neural networks. Career dead. AI was the least popular area of computer science during my PhD, and neural networks was the least popular area of AI. So that's where I was. But, contrarian, right? Why are you getting a PhD? Because you want to study something you're interested in, what you think, right? Stick to your guns. But a lot of people are, follow the leader. But anyway, so Gary, at some point, I was reading a paper which is a review, like it came out in the 1990s by psychologists who had hoped neural networks would teach them something about the brain, where the psychologists discovered something in lifelong learning known as catastrophic forgetting, where we train neural networks over time and then they forget. And so then they were like, well, humans don't do this. This is weird. Why does this happen? Well, neural networks obviously have a problem. And so I read this review paper. I think it came out in it was a review of compilation of everything known about catastrophic forgetting problem in lifelong learning. It came out in 1999. So I was reading this and was like, wow, this is a good problem. But it wasn't something until I'm like, one day I'll work on this. And after I became a professor, I had a PhD student who was like, I want to work on something exciting. I'm like, let's do lifelong learning. And nobody was working on lifelong learning, but I was like, we have to solve this because neural networks, if we want to ever approach what humans can do, you have to be able to teach a neural network over time. That we do not learn from a huge batch of data and you say, here, learn this, you're done. We learn incrementally over time. And so I thought, we got to solve the problem. Nobody's working on it. And so the rest, as they say, is history. So I got some of the first papers in the field after basically a nearly 20-year nobody writing a paper about it. At least not much.
So that was quite a ride, I would say.
I told you to ask me a long story.
No, but a very, very interesting story. Just listening that you had the opportunity to meet all these AI superstar when they weren't superstar. It's a very, very nice thing. So you talk about continual learning, and here I have a more technical question about the topic. This question actually comes from Andrea Cossu, another Andrea, just to keep the things and not to change too many things. He's actually a PhD student in continual and lifelong learning here in Pisa, and he asks, I'm reading it because it's quite long. What is the current efficiency of continual learning for long, non-stationary streams of data? How can you improve it? Can experience replay be useful in that respect? And before answering, I will ask you if you could please explain the question to the people who have not a background in lifelong learning or machine learning.
Sure. So I'll kind of like explain so now you have me going way back. So a little bit. So typically in machine learning, the way it's set up is we have a data set. And that data set is given to an algorithm with a set of training data. And then it needs to fit the training data. So it needs to, where the training data are the inputs and the desired outputs. This is supervised learning. Here's the inputs. These are your target outputs. So let's just focus on continual learning in the supervised setting for right now. And then you train on your training data and then test on another data set. Your neural network is then frozen in time. If you wish to update it with new data that the system acquires, usually you add to the data set and then scramble its neural network, it's kind of its brain, and then retrain it from scratch. This is expensive. So for very, very large neural networks, like, for example, many modern NLP systems require enormous computational power to do it. So, like Google scale to do it for real. And so this is expensive. And wouldn't it be better if the neural networks learn more like us? So I don't get my brain scrambled every time I want to learn something new, and I don't have to go through all my database, I guess. If I learn something, I can build upon my earlier knowledge and learn incrementally over time. Moreover, a fundamental assumption typically in learning algorithms in machine learning is that the data is IID, or stationary, meaning that the data is basically kind of shuffled. So it's not like you have a continuous experience with one thing you want to learn and then a continuous experience with the next thing you want to learn. It's kind of like, I'm going to learn this, and then I'm going to learn this next thing, then I'm going to go back to the first thing, then I'm going to learn the next thing. It's like all shuffled. It's as if you're kind of like trying to learn everything at once, but kind of shuffled to skipping between each things, not without any order. If you impose ordering, the systems, that's one of the ways in which you can get a conventional system to suffer from catastrophic forgetting in the most extreme case, where it's basically just forgets everything. So you get new data. Let's say you've trained it to recognize 100 different people, and now you have 5 new people you'd like it to learn. If you only train it on those 5, it will forget the first 100. If you just if you only train it on the new 5 people. So that's in a nutshell the issue. Now, so to fix it, then you're like, well, one way to fix it is just grow your database and keep training on the bigger database. But that doesn't get you much in terms of efficiency for improved time. You get better, you get the performance, but really it's still nothing like how we learn, and and it's not very efficient to do it this way. But efficiency can mean a lot of different things here. So there are one thing that makes continual learning difficult, or lifelong machine learning difficult, is the notion of efficiency, because there's so many different definitions of this setup. And one thing that I think is really important, I'm part of this project called Avalanche to try to get some standardization of things. I still think we got a long way to go. But is that you now basically in lifelong machine learning, we want to learn from data that's not necessarily shuffled. I believe the algorithm should be able to learn in the shuffled condition. So many of the algorithms that people are developing now for continual learning only can learn in a setting where things are ordered. Like learn person A, learn person B, learn person C, learn person D. Well, what about the shuffle condition? We don't do that anymore. We only work on the thing that doesn't work for the other methods. It's like, well, why not have one method to rule them all? So I'm very like, what do I want? How do I get what I want? Not like trying to solve a specific, like fix a deficiency in the algorithm, not make an algorithm that only works in the deficient case. So efficiency can mean a couple things. Does it rival a system trained on the entire data set in random order, even though it was in a structured order and saw things incrementally and did not have access to all the data up front, like it only had a little bit of data had access to over time? There's in terms of efficiency, so that's in terms of like learning efficiency. Can it rival this other system? There's other things that you might mean by efficiency, such as can it learn efficiently from less data? Can it learn more efficiently in terms of compute resources? Hopefully we want to target all of these, and at least in some of my papers I've started like using spider plots, is what people sometimes call them, or radar plots, to say level things saying how is it in each of these different domains, right? Because there's different, each of these should be measured in my opinion regularly, but there's different ways in which you can construct the notion of efficiency. My lab has made some of the only methods that targets the online learning setting, where you need to, which is like the most extreme setting. Some people say this is too extreme, but I'm like, I don't care. This is what we actually need, right? Go for the one that you need. And so basically my paradigm is the algorithm sees one example of a time and has to learn from it and then can't see it anymore. You may have a limited budget of storage where it can store some examples, but that budget is finite. So there's a finite storage budget that it's allowed to use, but it can't hold most of the data set in that little budget in terms of like memory. And then it basically needs to learn in data one at a time, see each thing's one at a time, as fast as it can, and try to rival the system that basically cheated and saw everything up front. So that's our goal. We've created a couple algorithms like this. One was a method called Remind that was published in ECCV last year. That's like a top computer vision conference. Another one's called Streaming Linear Discriminant Analysis, which can train on a big data set like ImageNet. Although it's not perfect, it actually works better than a lot of the continual learning methods that people published just the same year or in the last couple years prior to us writing that one, where this system trains in about 30 minutes on about 1 million images versus other methods which would take a week on the same hardware. So where it saw just things one at a time. And of course, we also test them in different orders, right? Not just so see every category in order, shuffle it around. You should still work. It shouldn't be like we only can do one thing. So that's kind of like my worldview for how to set this up for efficiency. I think you also asked about experience replay. Experience replay is used in Remind, for example, but it wasn't used in the other algorithm. I think it's not the most elegant approach in some way, but it's so basically an experience replay. The idea is, if you recall, I said something about having a little buffer of memory that you can then use to store some stuff. And basically the idea behind experience replay is you have this little buffer, you stick some stuff in it, but you can't stick everything, just a little bit. And then you use that little buffer of extra memory to facilitate learning, to avoid this catastrophic forgetting thing, to kind of like get into a setting where you're now able to kind of still do the shuffling kind of synthetically with your little storage buffer. It works, and our brains do some form of experience replay. We know this. Basically, there's a region of our brain known as the hippocampus, where it acts as an intermediary for memory, where our memories throughout the day seem to be stored there. And then at night when you sleep, and even sometimes while you're awake, where they are replayed to then train your neocortex for long-term storage. And if you, it's one of the places in the brain that can lead to epilepsy. And so people initially trying to treat epilepsy, they realize this and they're like, well, great, we'll just cut that part out. Probably don't need it, right? And then when they cut it out, basically that causes a form of amnesia where it's like the person will be like having a conversation with you, they're like, great, and then you leave. And then if you come back in the room 5 minutes later, like, hey, nice to meet you again. Hey, nice to meet you again. Hey, nice to meet you again. They have no ability to store stuff and learn things anymore for the kinds of like episodic memory, semantic memory, and things like that. Because they basically, for somebody who had epilepsy, they removed both sides of both hippocampi bilaterally, and this was what happened. So our brain does it. So a brain replays stuff, but there's still unknown questions. Like a lot of neuroscientists think our brain does not only replays recent things for storage, whereas the way it's used in deep neural networks to store for continual learning is we want to still store pretty much as much as we can throughout our entire lives in that little buffer, but not only the recent stuff. So there is a gap.
Okay. After this, let's say, after you before told us about your experience in academia, let's switch to the startup that you said during the introduction that you lead, Page. So can you tell us what is the role of your role in the company? You are AI Research and Development Director. So since probably most of us never saw how is done research in a company, and just like in academia, can you tell me what is your role and of course inside the company's mission?
Sure. So I was one of the first employees. So I mentioned now there's 180. When I joined 3 years ago, they said I was founded by one of my friends who had worked together at NASA Jet Propulsion Laboratory after I finished my PhD. We both became professors, and then he said, hey, I got a bunch of money to start a company. Can you help do this? I need somebody to lead the deep learning side and mentor people. I hired two. They're fresh out of undergraduate or master's degrees. They know something. One was an undergrad, one had a master's degree. They're excited. Get them to build a company for us. So I didn't have 180 people. I had two, and so that was in fall 2018. But over the next 6 months, we basically got us to the point where we created really, really, really strong methods for helping in computational pathology. So in computational pathology, so this is all kind of like, I know a lot about deep learning, but I didn't know anything about oncology or computational pathology. Basically, typically in my classes or in my research, the images we use for, we want to make the system learn on images, usually have a size of about 224 by 224. It's like a canonical kind of size. A lot of times, sometimes, but we might use bigger, like double or even 4 times that. That's rare. Most of them stick to this one size. But in computational pathology, the images are about 100,000 by 60,000 pixels. And you can't downsize them because you need to retain that resolution. So a lot of engineering challenges because they're microscopy images. And so what a pathologist does is they basically had been looking under a microscope at cancer or at this tissue to try to find the cancer. So it's like people like to say, there's a game called Where's Waldo? I don't know if you guys know this game, Where's Waldo, right? But the question isn't just where is Waldo, is Waldo even there? And so they have to play this game and try to find something really small. So we can't really just shrink the image to a 224 by 224 from this giant size. It won't work. You lose the signal. So our goal is to basically localize cancer and from vast amounts of data, because the company is a spin out of one of the best cancer hospitals in the United States. We have access to their data, because without data, you can't do much in machine learning. And so we have millions of these giant images and diagnosed by some of the world's best pathologists. And we train directly from diagnosis. So that's what Paige does. And on the clinical side, we're also working on tasks that can't be done with humans, right? The pathologist can't tell you how long will this person live, but we can try making deep neural network do that. So, but anyway, so that's the mission. And even with a small team, I was able to basically act almost like a PhD advisor and get them up to the point of creating better algorithms. But it takes a lot more than that. You know, if you want to get some, when you ask me the question, how is industry versus academia different? There's a huge range, I'd say, across different companies and how things are done. And in terms of how scientists interact with others. So like at a small startup like this, you know, you have to be kind of agile and be developing the rapid science side, but also you need to have people who actually know something about engineering to get it out. And so, but at like larger companies, a lot of times the scientists will still be kind of like in isolation, working on teams of just scientists, not as heterogeneous with like scientists, engineers, product people, all trying to interact to build things. So it really, really varies a lot. In some places, it's really like almost like being a postdoc who's very well paid, but working with others in collaboration and trying to get approval. In other places, it's kind of like with a lot of oversight, and really product people are kind of telling you, hey, we need this, make it better. So it's really, really, really variable in terms of companies, and it really depends on what is the company trying to do and what is their objectives. So that part is really hard question for me to answer in general. At Paige, the teams are, we have AI teams where there's like 1 or 2 scientists and several engineers, and a product person who helps kind of like define what are the needed criteria for the AI systems they're trying to build to work on these things. So it's a lot of heterogeneous. Other places, you know, it's like just write papers. You know, you're the decoration for our company. You know, it's like it varies. It really varies across the field.
Which are the tasks that you think that deep learning could be useful in treating cancer or other medical application? But specifically, I'm asking specifically about cancer because of Paige, of course.
That's what I know about, so it's the easiest one. So I mean, for me to answer questions about, so what's tricky is you really need to make sure, I mean, this is not a place where you can mess up. Like people could die if this system is misused. There's something known as the automation bias, where if it works reasonably well, most of the time, people will start overly relying on it and they won't double check it. So it can be a little bit dangerous if it's not like rock solid, as rock solid as you can make it. And Paige has the first FDA cleared system for histopathology with cancer we're using AI to do something, like to do diagnosis. But still, the pathologist has to be in the loop. So essentially, that system outputs a region that a pathologist should inspect and say, do you agree this is cancer or not? And so they have to look at it and kind of like confirm if they believe it's cancer or not. So it's almost like a second opinion. But you can get a second opinion every time. So that's the desired use case. But as far as how to build these things, a lot of times the big challenges are, A, you need a lot of data. And a lot of people, I mean, it's nearly impossible to do this without a source of data from a hospital, and that's difficult to get. It's like really hard, even in the United States. Like one of the selling points whenever my friend was trying to get me to do this was he said, I'm like, hey, Google's trying to do this too. I can't compete with that. They have infinite resources. They have people smarter than me. They have everything, right? And he's like, I have millions of images. They have fewer than 1,000. And that's true. And not necessarily true now, but it was true at the time. They had extreme, in fact, Google actually shut down most of their group there. So that's another story. But and they all left. All the leaders left. So to companies with data. But that's another story. But that was a big selling point for me, right? Like you can't do it without data. And public data sets are, to be honest, really small in this field, but across all of medicine, they're really small. And even once you get a data set, now you need to really make sure that it's robust across imaging equipment. So if you get a data set from only one hospital, a lot of times you will not have adequate amounts of data from other imaging systems. So it's not like our conventional computer vision data sets where it's like, here's 1 million images. Most of them are taken with different cameras. It's like you will end up with 1 million images with one camera. Different images, but one camera. And so now you're like, well, I want to run on a different hospital. They're with a different camera. So I had to come up with ways to deal with this kind of domain shift issue. Same thing with regard to, and that also introduces the whole just different hospital issue too. So not just a different scanning device, but also they use different kind of cocktails for the staining, slightly different, but now it looks a little more pinky, a little more bluey, a little less bluey, you know? And so you really have to get this. And this is part of what I did the first 6 months at Page, was really nailing this, getting good generalization across hospitals, across scanners, basically by reserving all the other hospitals and reserving all the other scanners as evaluation data, not training on it, so that I could know, will it generalize? I needed to figure out, how do I solve this domain shift issue? So that's the biggest issue, is really data. Once you can solve the data thing, a lot of the stuff is really just knowing the edge cases. You really got to check all, it's like overall performance is not everything, right? If they were like, well, we get an AUC of 0.99. That's like a evaluation metric, right? It's like, we got that. We had an AUC of 0.99. People are like, ship it. And I'm like, no. Well, it's got to have an AUC of 0.99 at the other hospital. It's got to have a AUC of 0.99 on a different scanner. It's got to be equivalent. And not only that, it needs to have an AUC that's really high for small cancers, even though they might be a minority of the data set, right? So if you start looking, maybe at the different cancer sizes, you're like, well, the big ones, it gets great. Well, those are most of the data. Okay, well, if that was the story, it's like, well, what about the small ones? If it doesn't work on the small ones, those are where you need it the most. So you really can't just try. You gotta check for everything to make sure that it's as safe as you can make it and as strong as you can make it. So it's just being a good empiricist, working with often a little bit of dirty data, not super dirty, but a little bit, and really measuring generalization effectively. But once you get that done, you just need a lot of data. Then, deep learning is kind of like a Swiss Army knife. It kind of just works. Just got to figure out how to do it appropriately.
So we just talked about how deep learning could be used to improve human health and the well-being of humans. Let's talk about the other way around. Do you think that there are any interesting ideas from neuroscience or from biological intelligence that could be borrowed by deep learning and used to improve it?
Yeah, absolutely. So it's a great question. Obviously we're a proof of concept, right? We can do a lot of things, including lifelong learning, far better than, or continual learning, far better than our neural networks today. And so there must be something going on in our brains that enables this. And there are a lot of things that where we do it well, but machines don't. Even in things that rival us or are superior to us. For example, I don't know if any of you are Dota 2 players. I'm not, but I have some semblance of it.
I've been.
I'll tell you a brief moment then. So OpenAI made a Dota 2 AI, and it can beat the pros, right? How much time? Well, I don't know when the game came out, but I don't know how much experience a pro could have at playing the game. Maybe 10,000 hours, 20,000 hours, 30,000 hours. I don't know. But what OpenAI found using their algorithm was that it played very much below pro level at only 10,000 years of experience. But after they approached 10,000 years, it was only after they had got to about 45,000 years of Dota 2 experience did it really start beating the pros. Now, but if you start changing the environment and things like that, let's add a new character, change the rules a little bit, probably won't work very well anymore. Like it may transfer some, but probably becomes sub-pro level, whereas the pros probably be able to recover from that. So that's one area that can use some improvement. They are deep neural networks, especially in this reinforcement learning regime, very inefficient learners. Not just a little bit, very inefficient. Other things that, you know, are just, this is like psychology, not so much neuroscience. We have curiosity. People have been trying to do this. We can teach ourselves. I have a 1-year-old child. You know, she appears to be like practicing how to say words. You know, she's repeating after me. You know, cat. She's been trying to say different C. She's been working on C words recently. So, you know, we are kind of like self-motivated learners, and while people are trying to work on what we're calling self-supervised learning, it's very constructed. Like it requires a lot of engineering to figure out what those supervised tasks are. And I don't think that yet kind of like rivals the flexibility of humans. Other things that I think are relatively unexplored in deep learning are the role of neuromodulators, the role of attention. We talk about attention, but attention in the brain is much more complicated than attention that we use in many of our neural networks. Neuromodulators are like, while dopamine has been studied a little bit in reinforcement learning, but we also have like serotonin, norepinephrine, epinephrine, you know, a bunch of other ones that all kind of like alter how our neurons behave. Like they're like antidepressant, even like those things, like those are the things that like, they cause things to change their behavior, but they don't actually cause like them to, they're not actually the transmitters that send signal, right? And so there's a lot of things where, you know, it's like, why do our brains do that? Deep neural networks don't do that. We have many different kinds of neurons in our brains. Deep neural networks usually don't. We have many different kinds of, we have a bunch of different things in our brains that deal with clipping connections and doing things like maintaining and doing different things and reconnecting things after pruning them. Deep neural networks don't. So there's just a ton of stuff going on in their brains, but now that aren't incorporated in the deep neural networks. But the real question is why? Is it due to physical reasons that these things are needed, or do they have functional purposes? For example, it's just, you could ask the same question about what do planes need to learn about from birds, right? Well, both have wings, right? And so, you know, if we didn't see something flying, we may not even thought a plane would be a thing we could do. And obviously the idea of wings kind of like was very inspirational probably to see birds flying around with wings. But planes don't flap, you know? So you gotta like figure out what is the functional thing versus what is, so the wings, flapping provides, you know, propulsion, whereas other methods provide propulsion, but the wings still provide a lift, right? So, you know, you need the wings to provide the, you know, to enable the lift, but not necessarily the propulsion. So both have wings. So there's like things where it's difficult to tease apart the difference between why is this in the brain? Is it for only a physical reason? Is it for a functional reason, or is it for both? And it's really hard. Like, for example, spiking. So neural networks that we have are binary in our brains, mostly, instead of sending like continuous connections. And there's a strong belief that that's just due to it's hard for electrical signals to propagate. And so basically that's a more efficient way to propagate electrical signals in wet hardware efficiently is through spikes versus continuous values. Actually, our eyes, because there's don't have to travel very far, actually have some things that use continuous values. Graded potential is what they're called.
Okay, a curiosity. We noticed from your curriculum that you have also a degree on philosophy. So just a question about ethical AI. What do you think about ethics in artificial intelligence? Do you think it's a big problem and should be, I mean, not a big problem, but it's something that should be taken into pretty much consideration?
I think it needs to be definitely taken into consideration, and certainly it depends a little bit on each individual use case, but it certainly 100% needs to be taken into account with systems we're deploying, whether it is, especially in cases where there can be social implications for these things, we really need to think about it. And especially for systems that are deployed that operate on faces or making decisions about, you know, who gets to get out of prison early, who gets this loan, who gets this, who gets that. But it's a similar problem to like medicine when I was talking about checking all the edge cases. You got to check all the edge cases, but that's sometimes really difficult to do because neural networks will find the shortest path to minimizing the loss. And that sometimes, so they're basically, how do I optimize performance to replicate that input-output relationship that you want? And so sometimes they'll cheat and find weird things. For example, there's this one case where people were like, we don't want race as the input to the system. Race within the system might be racist. We won't use race. We'll use zip code. We'll use zip code. Well, it turns out people of certain racial demographics tend to be more concentrated in certain zip codes. What did it end up learning? Race. So, you know, it's like you really got to test this stuff. So it's not just in the inputs, but you need really robust tests across as many edge cases as you can come up with, and probably just really start testing it internally really vigorously before releasing it. Because time and time and time again, companies are getting burned on this stuff. I mean, not only is like facial recognition, like you got a lot of ethical things, but I mean, take Twitter's cropper. So Twitter thought, okay, great, we're gonna have an image cropper, we're gonna release it. It's gonna be based on something on the notion of saliency, what do people like to look at? And it ended up being both sexist and racist. And so, you know, people just did not take a big image, crop it down to the things most interesting. And so people did a bunch of tests after Twitter released it, not people in Twitter apparently, and Twitter had eventually take it down after all the controversy. I mean, the same thing happened to Google multiple times. My understanding is now Google has an ethics and fairness review for all AI systems after many, I guess, mishaps. This is my understanding. So I don't know if it's true or not, but I'm sure the same thing's true at Facebook and other companies. But I think it's critical. We're releasing these things. AI in military applications, there's a lot of ethical questions about that to me, in my mind, that need to be considered. But yeah, I don't know if I'm well equipped to deal with it, but I think about it. I was once asked to do deep learning on a bomb. I was like, what does the bomb need to learn? And then I did not do this project. I'm like, I have no interest in these things. Why do you want me to do this? Why do you want to do this? I don't even know.
Yeah, as it usually happens, the problem most of the times are humans, not the technology itself, how humans use the technology.
Exactly. One thing I've started doing, so in my deep learning class, most lectures like start with both I have a positive application AI and a negative application. Like there was this face recognition company, and they're like, we were able to track down this child abuse criminal by using our facial recognition technology. We found him, but tracked him down. All we had was a snapshot of his face. Also, you know, we can use the same technology to find political operatives we want to get, you know, deal with. We could use the same technology. I mean, there's this example where somebody used this technology in China, because they're very well set up with cameras everywhere, to shame somebody for wearing pajamas. So they posted her all of her information and stuff, where she was walking around pajamas outside saying, you know, I guess do better. You can find it if you Google this. It's like, really just, so find criminals better. It sounds good, but it ends up being like ripe for tons and tons and tons of abuse, just enabling that capability. So everything though has like, you know, just like nuclear technology, there's pros and cons, you know, it's like, what do you do with it? And that's humans. And oftentimes we don't necessarily make the right decisions.
As we are entering the final step of this interview, I would like you to imagine a scenario where you have the ability to travel back in time, and you have the possibility to write to the Christopher KANAN from the past, which is about to start his PhD. You have the possibility to write him a written note and leave it on his desk. I have two questions. What would you write? And would the Christopher KANAN of the past follow the advice?
It's hard to tell. I assume, so I also don't know what the context is. This is about research, science, or life
Let's
decisions.
say it's an advice about research and how to
Good.
be successful.
Otherwise, I leave myself a note. Keep buying Tesla stock.
Yes. Invest in Bitcoin.
I bought some when I was graduate student. Graduate student, you're like in Val poverty. I didn't have much money. That is worth actually a decent amount now. Probably more money than I made as a professor. But just this tiny amount of money, putting some Tesla stock. I didn't have any money. But anyways, just keep buying it. But as far as research goes, there's a couple lessons that I learned as a student. So I don't know what the note would say. It's a hard one. But there's two things that I learned over the years that really were kind of painful lessons to learn. One is kind of like not to lose focus of. So it's hard to know if I would. I don't think I would listen, right? Because until you lived it, I mean, otherwise I would be able to get graduate students to listen to me more, right? But until you live it and interpret it, it gets hard. You don't like, old person, what are you talking about? So don't get too focused on the weeds. You really got to keep your eye on the big picture. So that's one important thing. Like one summer, I spent the entire summer dealing with a statistical question that was ultimately of no importance. But I thought it was important, but it was really in the weeds and totally unimportant to my goals. Like I got lost in a rabbit hole because I was trying to figure out how to do something when really what I was trying to do wasn't necessary. And the other one is to always get your ideas out there, even and persevere. So one time I had this great idea and where I thought it was a great idea, I worked on it independently, wrote a paper, submitted it. And the reviewers said, this makes no sense. You need this or that. Well written, but it makes no sense. And I was like, oh gosh, I guess I'll just never do anything with this. Put it on archive. These reviewers hated this paper. A paper came out a couple of years ago for neural networks. So I wrote this paper in I think 2008 maybe, it's made a AAAI, and then they rejected it, and it's still probably somewhere on my hard drive. I put it on archive. I should have put it on archive. But anyways, a paper came out just a couple of years ago doing very, very similar ideas. It's now been cited like 1,000 times. So different people reviewed it. Like people who were complaining about my thing were like statisticians. Somehow got sent to some statisticians who cared about something weird that I didn't care about. So just don't lose faith in yourself. And always get your ideas out there. Don't quit. Don't listen to the naysayers. I guess that's really the lesson. I guess I'd already kind of believed that a little bit, but really don't listen to the naysayers.
Thank you, Professor, for this wonderful interview.
Yes,
it's really
really.
been a pleasure to listen to you and all your expertise, and experience. It's really been very interesting talk, at least from my point of view, but I guess also from many of the audience point of view. So it's time to close this interview. Just a message for the audience. Stay tuned, because in a few minutes we will be back with a new guest. Bye-bye.
Bye. Thank you so much. This was fun.
Welcome everyone to this new interview of the 4th PhD event of the University of Pisa. Today we have Alberto Massida here with us. Thank you, Alberto, for joining us for this interview.
Thank you for having me.
So, if it's okay with you, I will start right away with the first question.
Sure. Carry on.
Can you please introduce yourself a little bit, your career, your scientific interests?
So, hello, everybody. I'm Alberto Massida. I'm 38 years old, from Rome, and but currently in London since I joined Facebook, now Meta. My career has always been identified by I think, a site reliability engineer, production engineer. I was the Linux guy, the DevOps that fixed your infrastructure and took care about keeping your machine in production, developed features and also performance-oriented non-functional features anywhere I've been. My academic interest has been heavily influenced by the first place I worked at, which was Translated. Translated is a language service provider, a translation company. You send the document to be translated. They pass through a network of human professionals that translate the document and give it back to the customer. And they were very different from all other language service providers, in which they were heavily technological. So they developed a lot of assistive systems to automate the translation workflow and also the translation, the act of translating per se. So they developed their own tooling, their own machine translation solution, their own keyword analyzers, and they were very, very geared into natural language processing. That was my first academic love, and is the thing that I carried out for most of my careers along with me. So the Linux guy, Vim, has always been a background. It is now that I'm Meta, but I have decided to pursue it on a bigger level, and so I enrolled in a PhD at a very late stage of my academic life last year. And so pretty much I'm pretty much an outlier in the usual distribution of academics students. And I get to collaborate with also very, very high talented researchers, like at the Facebook AI Research Lab, like the FAIR. And very exciting to be there. And that's basically what I'm from a professional standpoint.
You said that you started a PhD last year, more or less 10 years after you graduated. And so why you changed your mind and start to this PhD?
So I always flirted with the idea of doing a PhD. But I was convinced not to do so because at the time we were collaborating with scientists and with researchers. So I was convinced not to do so in order to keep focusing on my job while still being in contact with the research topics. After some years, so I kept going on as a self-paced learner. Then I decided to take a step further, and I attended 2 months full immersion program into the P School at P Campus, always in the translated universe. And years later, that I left Translate actually, which was very funny. And after 2 months full immersion program, I started, that helped me in setting a foot in the deep learning community and deep learning research branch. Before that, I was still on the very statistical and traditional machine learning, but not driven by neural networks, NLP. After 1 year, I decided that to get to the other level, to push the limits of the self-paced learning, I had to join some academic institution to be in contact with other people, to try to publish some serious research on my own. And so I went back to the university where I had some contact left there, since I used to hold some seminars and courtesy of my artificial intelligence professor. And we talked, and I managed to join without any grant. So I joined the PhD program without any funding, without any granting, like free part-time thing. And that's basically it. At the time, I wasn't still in Meta. I was in a previous job, was an ugly place that left me so much time to think about else, and that it was the time I was doing the activity of my research. Then I joined Meta, and I hit a hard stop because the ramp up here is really, really tough, and I had to dedicate 100% of my energy to ramping up in the 6 months since I joined.
Yeah, I imagine the competition is quite.
No, it's not a matter of competition, really. In Facebook, I've never seen an environment with so many nice people. It's the idea that you don't. It's a universe. It's a galaxy, autonomous. Facebook, Meta, pardon, doesn't really use open source project. They release open source projects. So in whatever you have studied, whatever you have used outside, in Facebook, there's a different version tailored on their needs, very much evolved, and very different from everything you have ever seen. Like I know Kubernetes. I've used Kubernetes for years. They don't have it in Facebook. They have Tupperware. They're the container system. They have Hive, but it's not Apache Hive. It's a much bigger version. And there's no Kafka. They have the Scribe, which predates Kafka, actually, and on and on and on. So you just keep being showered with the new technologies that you're supposed to learn very fast to be productive. And so you keep scraping wikis, attending to seminars, attending to internal courses, and this really saturates 100% of your CPU and 100% of your mental I/O that you can have. And that's why I had to put under ice my research activity, because it was just not possible to keep doing as a part-time research. I do it nighttime. It's a moonlight at present stage, but I hope really to be able to get back on track.
So can you tell us, describe a little bit more in detail your PhD project?
Yeah, so it started as a study over GANs, over generative adversarial network. So I wanted to research the condition of stability in GANs, and particularly regarding the function space application. So most of the GANs have this problem of stability because they try to optimize a function in parameter space. And while it is guaranteed, actually, the GANs converge if you do that in function space. So I wanted to say, okay, can we just take it the opposite way? Instead of keeping optimizing the parameters, let's try to keep optimize the function. So let's go into an ensemble perspective. And that might bring some insights, some improvements over the current state. That was my initial hope. Then actually I got since I was a little pressured about releasing something, I had an old idea in natural language processing about machine learning on code. So code analysis with machine learning. And okay, let's just finish this project so I can have something ready to release. And this this branch, eaten up all the energies. So I'm still into this study that actually sprung 3 different lines of research, 3 different projects. And so now I had to start with a topic. I'm still finishing on natural language processing on code. So once again, natural language processing crept in and imposed itself as my main topic of interest. I guess it's really difficult to embrace new topics when you know you are skilled into something, because it's too strong the temptation of using the knowledge you have already gathered during the years.
Yes. And when did your interest in machine learning field start?
In translated. So in the first company I've joined, this language service provider, and they were releasing they were building all of their keyword analysis tools or their language analysis tools. It was 2008. So Google Translate was there, but nothing else beside that. There were a lot of the translation tools that were proprietary. And so we thought we could do better and build stuff on our own. There were some machine translation toolkits that were on which Google Translate was based upon. For example, there were actual open source projects, like the very glorious Moses toolkit used to build phrase-based machine translation systems. And this was 2008, like 6 years, I think, before the big wave of neural networks and deep learning-based machine translation. And I was exposed to all the beauty of the Bayesian mathematics, all the word counting techniques. It was a very, very formative experience because I was able to control everything from infrastructure perspective, because I was the Linux guy that had to put stuff in production, but also being able to code these models out, because it was like a 4-people technical team. So if it wasn't me, it was somebody else in the same room. And it was a very, very small team, but very, very aggressive.
Yeah. By the way you describe your research and your activities, I can feel that you're really involved in it and you're really passionate about. So I think a natural question arises: why didn't you start the PhD right after you graduated from university?
That's a nice question. Actually, I didn't know the field. So I started working after the bachelor, because I already spent 4 or 5 years into the bachelor degree. So I wanted to go to work. I didn't want to touch any books anymore. As a first experience, I landed in this company and I was tasked with building a search engine. So I started delving into all the information retrieval, and there was no Elasticsearch at the time. There wasn't even Solr. There was a Lucene, the bare Lucene library. So all the beautiful world of the vector space model, it was the very first experience I was exposed onto. And so I started building stuff, and I found very satisfying building stuff. And I was quite happy with the knowledge I was able to gather, because it was enough already. I was just ramping up as a professional because I was just out of university. Then I went back to complete the master degree, and I kept working, but my main source of satisfaction came from work. So I guess that the main reason to pursue a PhD probably lies into the wave of the deep learning, where a complete new wave of stuff brought temporarily everybody on par, because there was nothing. So everybody could just join the fray, because for this distortion effect, since there were no toolkits, there were no data sets, the GPUs were just beginning to be used as a professional deep learning hardware. So everybody was just on par. And I thought that was a good chance to join something without being left too much behind. That probably was the reason. Otherwise, it would have taken years and years and years of knowledge building if we still were in the pure statistical machine learning, the traditional machine learning, to actually build some corpus of knowledge. How wrong I was, I was really wrong, because the machine learning statistical thing is still there, is used side by side. Think about just like, for example, all the vector quantization into the deep learning, all the technology which is based on quantization derives from the traditional machine learning field, but now is used proficiently into a deep learning thing. So you just have to know twice. So the assumption that just focus on deep learning would have brought me on par very quickly was completely wrong. But in the meantime, I had grown a passion for study, for reading papers, and for diving headfirst into the topic.
And do you think there is maybe too much hype in machine learning at the moment? Because that's the way many of us feel.
It's just impossible to prevent the hype from entering a specific field. Think about, let's just take other technologies like the containerization or the cloud. No, the containers, I mean Docker and Kubernetes. Docker and Kubernetes were hyped so much that they would have solved every problem in every infrastructure. I think that Docker did a very good job in solving a lot of problems for the infra guys. Also the cloud. The cloud was meant to solve every problem in infrastructure for people that own the racks at data centers. It was not the case, since you need to build a lot of knowledge and lore around the cloud. So you solved a lot of problems. Now the cloud is your main problem, because you need to know, to understand how to use it. It's the same for deep learning. You need to understand how to use it. It's not a black box. It's really, really powerful. It's not a magic wand. I think that a lot of progress is still being made. So we haven't reached a plateau yet. So think about the attention, think about the transformers, and all the exciting research that stemmed from the attention models in natural language processing. For the attention did to the NLP the same thing that the convolutional networks did to the computer vision. It just enabled a whole array of potential infinite stuff. There was a lot of hype that, okay, ConvNets have solved all the problems for the computer vision. No, definitely not. Same thing for the attention and the GPT-3, the glorified pre-trained language model from OpenAI. No, it didn't solve all the problems. It's a very, very powerful tool, and we just need to learn its limitations and its potential. So a lot of the hype is always unjustified because all the technologies, all the hype of technologies, sooner or later will disappoint you in your expectations. Think about the object-oriented programming, the same. That was the only paradigm that would have succeeded. Wrong. Functional programming was there to stay, and now we are witnessing the two paradigms being merged together. So the hype is always wrong. Hype will always disappoint you, but that doesn't take away all the value that technology carries out with.
Don't follow the hype, someone could
Don't
say.
follow the hype. Just close that website immediately.
And listen to your words, Alberto. You are a man with two souls. The one is the researcher, and the other one is the employee from in the industry, in some sense. And what are, in your opinion, the three main differences between industry and academia?
Oh, that's a tough question because I will end up disrespecting somebody. I think that in the academia, everybody's pressured in. The metrics are different, I think. There's a lot of pressure in both fields to produce results. It's just the metric which is different. In the academia, you can publish a paper and everybody's happy. You've done your job. it's a lot of Kober effect. You know, the Kober effect. Whenever you just optimize, the Kober effect is where I think in Malaysia there were a lot of cobras around that bite people and kill people. So the government started pay bounties for killing cobras and bring dead cobras to police officers in exchange for money. The effort was to kill all cobras to solve the problem once for all. What they obtained is that people started breeding cobras. Because whenever you try to optimize at all costs for a metric, so the amount of cobras killed, and not the population decreasing of cobras, people just push for more cobras. The Kober effect is whenever the metric becomes the target becomes a metric. No, sorry, the metric becomes the target, and so it ceases to be a good metric, because you will just optimize for the target regardless of any context. So in academia, there's a lot of pressure to publish papers, even crap papers. Those are fine. And that is the problem that in academia you see. Try to come up with good research and resist to the urge of publishing anything as long as it's publishable. In industry there's a similar problem. You have to release stuff continuously, and since the best bet is always the less innovative stuff, you are pressured in releasing the same flower, a different flavor of the same thing seen over and over again. Do we really get another web framework? Do we really need a new NoSQL database? And that's the problem you see in industry. Do we really need another travel recommendation website? And on and on and on. So the problem is that we're different metrics, but same problem. Everybody just optimize for the metric as a target, and that's the main difference. Besides that, I see the same behaviors around. There's brilliant people, there are slackers. The distribution of humanity is constant.
So you have to be very careful with the objective function that you choose to optimize. This is true in deep learning as well as in real life.
It's unfortunate that this is not something that you get to pick. You as a researcher don't get to pick your function. Somebody else has decided you must publish or perish. So what do? You end up running the risk of not seeing your grant extended and being a clown in front of everybody. No, you don't. So you don't experiment. Then the experiment blows in your face. Then the time has already been spent. So you tweak the data at the maximum extent in order to show that something has been achieved nevertheless. You handpick all the good outcomes that you had, and you submit those. Because you cannot do anything else, because you are constrained in 6 months to produce something. It's unavoidable. I think that at least I don't know if the university researchers are better off than industrial researchers. I really don't know who's suffering most.
It's probably a different kind of sufferings, but still.
They are pushed to release things at 6 months time boxes. I can see that even in Facebook, they release stuff with a conveyor belt. I think they enjoy it, but it's different for them. Their job is to produce papers.
Okay, so now I have a little more personal question. Let's say. Many people, both in academia and in often big tech companies, are known to suffer from the imposter syndrome. Do you know know this phenomenon? Can you tell us a little bit about it? Do you suffer from imposter syndrome?
If I suffer from imposter syndrome, I am literally eaten alive by the angst.
Okay, I'm not alone. Thank God.
I think in Facebook they take it very seriously. From the day one, when you join the company, you are put into a boot camp so that you can ramp up. And the boot camp lasts months, and they repeat constantly, don't feel the imposter syndrome, don't fall to that. Please be aware that everybody, all of us have been there, and so please don't feel that you are the only stupid that can pick up stuff, because we know that we are asking you that much. You have already won, you have already passed the selection, so you are here, so don't feel pressure. Does this work? No, not at all. Not at all, because you are surrounded, you already know that you're surrounded by the most brilliant people. You already know that you're surrounded by the most challenging problems. You see everybody running at full speed, and that's you with a pen in your hand, not being able to carry out anything because you don't understand the place that you have landed. You get to choose your team. Then you go, you start studying the documentation, and after a couple of weeks, you don't understand anything. Then they give you a buddy to follow you, and after a lot of explanation, a lot of repetition, you start understanding something that you finally go to the code, and you don't understand anything in the code. So it's really difficult not to feel stupid. At least I constantly fight with this feeling. After 6 months, if I turn backward, I see that I'm in a better place where I was 3 months ago and 4 months ago. So I see there's a progress. I see there's clear progress and clear now. I remember the first time that my mentor opened the editor, turned on virtual machine, show me how to clone the repository, how to edit the stuff, how to submit patches. And I saw all of this. There's no way I'm going to learn this. After a couple of weeks, I was able to do so. So this feeling of not being up to a task is constantly present, but I can see that it definitely fades away time over time. So the imposter syndrome, yeah, is there. Is of course is there. They try to make their best not to insulate you from this feeling, but
you get used to it.
Yeah, I guess that you get used to it. Yeah, I guess so.
So we have the last question. This is also a personal question in some sense. We would like to ask you if there is a moment that you carry with you that has been a great opportunity of learning for you.
Yeah. This helped me out when I was suffering from this imposter syndrome. And so I realized this thing. When I was a kid, I used to watch Formula 1 with my father. And I used to make a lot of fun of the pilots that always arrived as a last place. At the time, I'm 38 years old, so I'm really old. There was like the Minardi. There was this motor team that never made to complete any race. There was Fisichella that was running in Minardi, and it was basically a team for new talents to show up into Formula 1. Also, I think Ralf Schumacher was in the Minardi, then disappeared. And I used to make fun of them because look at those. They're not even complete. They're always crashing even. So they're not even. Why they are even racing? Why they're bothering joining Grand Prix? In Grand Prizes, I don't know what is the plural. If they never make to the end. then when I, some years ago, thinking about that again, I realized that that was the Formula One. Those were the 20 best pilots in the world. Even the last one, the 20th pilot, was a monster compared to all the other pilots in the rest of the world. So it doesn't matter if you always arrive last, because you are arriving last as a Grand Prix pilot in the Formula One, the most prestigious competition. Even if you crash your car, you were flying a fighting airplane on wheels, and you are competing with the best and most brilliant, so you can be proud of yourself. So here in Meta, when I realized this, a lot of pressure washed away, because I realized that, okay, I'm in the Formula One. So it doesn't matter if I totally suck compared to all my colleagues, because this is a place where it's not so easy. So if you're doing research, if you're in the university, think about all the people in the industry, how many developers are out there, and how many researchers are in the university. You are already part of an elite. So try to breathe out your all your angst, because you already made that. You're already made into the research, into the university. So you're already part of an elite. That's it.
Well, I think that's a very good ending thought to leave the audience to ponder a while upon. So thank you, Alberto. Thank you for joining us for this really both entertaining and insightful interview.
Thank you for having me.
For the audience, stay tuned for the next one.
So, hi everyone, and we are here, Andrea and Daniela, today with Dr. SOLÈNE NEYRET. And thank you very much to be here with us and to participate to this event, PhDCast. So I will start with the first question, that is, if you can talk us about yourself and about your work.
Okay. Well, thank you very much for the introduction, and thank you for inviting me. I am very happy to be here today. So I am currently working as a postdoctoral researcher at Métiers Institute of Technology, and I have a PhD in social neuroscience and virtual reality. I completed my PhD in Barcelona at the EVET Lab, which is part of the University of Barcelona, under the supervision of Professor Mel Slater. And during my PhD, I was working on the topic of changing perspective on oneself or on others in virtual reality. And now, as a postdoc at Métiers, I work on the emotional training of team sports athletes in virtual reality.
So let's start with the first question. Virtual reality headsets are spreading fast among the population, but we mainly see video game and entertainment applications. What is the research landscape on virtual reality, and what are the potentials?
I'm sorry, what is the research landscape, you said?
Yeah, what is the research landscape on virtual reality, and what are the potentials?
Yeah, okay. So as you said, right now, like the use that we see the most outside of research is for mainly for entertainment and video games. But there are more and more applications that are like starting from the research field, but will become of common use, I think, in the next years, like very soon, in fields, for example, that are about training the emotional capacities of people that work in extreme conditions through exposition in virtual reality. So, for instance, we are seeing more and more applications for doctors to train when they are faced with an extreme situation where they have to take a very fast decision that supposes like a life and death kind of decision. So in VR, they can be trained and have like many stress factors around them, and they trying to take the right decision. Like they have a patient that is about to die, and then they have like a member of the family that is there, and also like panicking, and you know, like the whole setup is like very stressful. And if they are repeatedly exposed to this, then they can train their emotional reactions and therefore their capacity to cope with stress. So this is one application that I think will become more and more common. So this is like, you see many applications that are for education, that are developed like towards education. VR is an interactive technology, and we know that when a student is like interacting with an environment, then the memorization works better, and all the whole learning process is enhanced. So I think those are applications that can become common, like in education mostly. Yeah, and I mean, of course, there is also in psychopathology. There are also many applications that are becoming more and more common, like for like cognitive behavioral therapy, and like being exposed to situations that are stressful and work with a therapist on this situation. This is also like a field that is very developed. There are many fields, like I cannot like tell all of them, but what I can say is in research it has been explored, and now it will start to come to the real life, so to say, and to be used by many people.
Okay, thank you.
One interesting thing is about what you talked about stress before. So from your paper, what I've seen, you made an experiment where you let like people, I guess men, to be embodied. So to inside, of course, let's remember the context, virtual reality, to be embodied in a women's avatar. It will let them experience the harassment from a group of men. So can you talk us about this experiment? What were the results? For example, did the participants really feel harassed? And what would happen if instead of being embodied in a woman's avatar, they were embodied in a man avatar? So does being embodied in a women avatar makes actually the difference?
Yeah, okay. So in this experiment, we wanted to see if like if we would reproduce a scene of verbal harassment in virtual reality, harassment from a group of men towards an isolated female, we wanted to see if being embodied in the victim of the harassment, so the woman, the people would then adopt more prosocial behavior than a later scenario that was happening 1 week after. So to answer like to your first specific question, yes, the participants did feel harassed. How do we know that? Well, we made a qualitative analysis of the interview that we had afterwards with the participants, and we had three conditions, right? but like the two important conditions here are the participants were in the condition that we called outgroup. They were embodied in the woman and perceiving the scene of harassment from the perspective of the woman, but they had seen the scene of harassment from the perspective of the group of guys just before. So they were reliving the scene of harassment from the perspective of the victim. And in the in-group condition, they were seeing the harassment scene, and then they were reliving it, but from the perspective of another member of the group of guys. And what we saw is that when we asked all the participants how they felt in the harassment situation, only in the outgroup condition, we had the participants saying that they felt harassed. And spontaneously, this word came out. And we saw that there was a high frequency of the participants reporting that they were feeling harassed. So from there, in a qualitative analysis, then you can do like what we call a word cloud, which is we put the biggest, when you have like the more frequency of a repetition of the word, it appears the biggest in the word of cloud, in the cloud word. So there we saw that this is reliable results to say that yes, the participants did feel harassed. And it is good to run this kind of like unbiased interviews just to say, okay, spontaneously, how did you feel? And then you see that spontaneously, like most of the people say these words, and only in one condition. So there, it is quite reliable as data to say that yes, they had this sensation. If they would have been embodied, like if it would have been a guy that would have been harassed, I think they would have felt harassed as well. It is just the perspective of the victim, like you're just receiving an aggression while you are in the virtual environment. In this case, it's a verbal aggression, so I don't see why they would not have felt harassed. But in this case, we wanted to play on the in-group, out-group, opposition. So this is what we chose, why we chose to do men and women, but it could have been any opposed groups, like because we wanted to work on the impact of belonging to a group, like the in-group effect and the group pressure, and how this can affect behavior.
Okay, I have another question related to that one. It seems to be simpler to solve other problems than ours. And you let your participants discuss their problems to themselves, but embodied in Sigmund Freud. And can you tell us the impact of this embodiment?
Okay, so in this experiment that you are referring to, we wanted to see if discussing a personal problem with oneself would have a positive impact and would help participants to find a solution to their problem. So what we did is that we put the participants in a virtual consulting room, and they were sitting in front of an avatar of Sigmund Freud. So this figure was chosen because a little survey was run in the psychology campus of the University of Barcelona, and people were asked. So this was previous to my research. Like people were asked if you would have to ask someone about a personal problem, who would you ask? And then, in the survey, a bigger percentage of people answered Sigmund Freud. So this is why this figure was chosen. So the experiment that you're referring to, there is the avatar of Sigmund Freud, but the aim is to see if one is embodied in Sigmund Freud, what impact will it have on the solution that that one can find about a personal problem. And so what we saw is that when people were having a self-conversation where they could explain their personal problem and then switch and enter the body of Sigmund Freud and see themselves from outside explaining the problem, then they would find more solutions to their problem. They would somehow access some knowledge that they would not have accessed if they would not have got outside of themselves. So we know this because we had a control condition where the participant did have a conversation with an avatar of Sigmund Freud as well, but they were not switching between the bodies. They were staying in their own body. And it's important that in this experiment we had scanned avatars that looked like the participants. So they would see themselves in a mirror to be really embodied in their scanned avatar. And then when they would go in the body of Sigmund Freud, they would see themselves in the mirror as Sigmund Freud, but above all, they would see their scanned avatar in front of them explaining a personal problem. And this is very important because they could see like their appearance, and they could see themselves with all their body language, like how they move their hands when they explain a personal problem that is a bit stressful, and how their voice is changing because they are a bit stressed. Like all this, they could suddenly perceive it from outside, as if they were listening to another person. And this is what had a big impact on their capacity to then find solutions to the problem, because they were embodied in a figure that is supposed to be able to help, but more than anything, because they were seeing themselves from outside as another person. And then a whole new like set of like a whole new how can I put it, like set of predictions about the personal problem. Like when you have a problem, you are like kind of caught into predictions, like I have this problem and I cannot solve it because there is this and that, and this is it's impossible. This is what is called in like cognitive behavioral therapy automatic thoughts. So these are like the brain takes like shortcuts like very easily and goes to these automatic thoughts, and okay, I have this problem, yes, I will never solve it. It goes very fast. And so it's like it's as if being outside and seeing oneself as another person, the participant could somehow escape these automatic thoughts and get a whole new perspective on this problem and say, wait a second, okay, there is no reason why I could never solve this, because I could do this or I could do that. And then they would have a conversation with this, like between the avatar of Sigmund Freud and their own avatar. And through this conversation, they would, for instance, ask questions like, okay, but do you think you could maybe do that? And then they would go back to their scan avatar and answer, ah, yes, you're right, I did not think about that. But then there is that problem as well. Then they would go back in front. Ah, yes, there is that problem, but look, maybe you could see it from this other perspective, and maybe you can do this and that. And going back and forth, then they would like construct a complete new approach to this personal problem. And this is what then helped them to find a solution.
Okay, thank you.
That this kind of switching bodies are also like to be embodied in a different, like being in a different body, switching bodies. This is like something that we really can't do like in reality. So that, like in your opinion, like with your experience with reality, do you think like in the future we will move like our lives in a virtual reality world rather than the real one. What do you think? What is your feeling? I mean, this is more about feeling.
So what do you mean? Will we move our real life to virtual reality?
It will be the future with a virtual reality, like we see sometimes in the movies.
Okay.
Just like a small point.
I mean, I do not know. It's very hard to predict the evolution of a society, right? I think that it will be more and more affordable to have headsets at home. This is already happening, and this is most likely more and more people will have VR headsets at home. So this will change a bit the use that we have of virtual reality, and then it will depend on which applications are available. For instance, this self-conversation application, do we want people to have it and like go in the evening at home and have a conversation with themselves about something that happened during the day and say, yeah, I'm frustrated because this happened and I don't know what to do, and then go and have a switch and have a conversation with oneself? Do we want that? I don't know. But if your question is if the whole reality will be replaced by virtual reality, this is already possible, like technically. I've seen a journalist that has spent 24 hours in the metaverse, but then and she really did it. She slept with the HMD on, and she ate with the HMD on, and she found ways to really stay inside. And then her head was aching, and it was really not such a nice experience to stay so long in the virtual reality. So technically it is possible. Now, is this what will happen? I don't think so, because virtual reality cannot replace reality, even if it replaces the whole sensory stream that you are receiving, and you can totally imitate the perception of reality in the virtual reality. But I think virtual reality is more a tool to show you aspects of reality from another perspective, and it should stay like this. It should be just a tool to get outside of the reality a bit, but it should not replace it. And I think there are many elements in the reality that cannot be replaced, that cannot be represented in the virtual reality.
Yeah, of course. I mean, it's too complicated. It was a more a curiosity question, especially with this metaverse thinking.
Yeah. Like this, I think it's a tool that can allow to have it on the side, right? But for now, spending a lot of time in the virtual reality is really costing a lot to the brain and to the eyes, and really it is we cannot stay so long inside. When I started doing research, we had a limit of 20 minutes. We could not leave participants more than 20 minutes inside. Now the technology has evolved, and maybe we can stay a bit more, but staying all day long in there is really crazy. And also, I mean, there are ethical questions around this that are very important, because for kids, for instance, what do you develop as a perception of the world if you are immersed in a virtual environment? And I mean, I recommend you to look at the publications that are increasingly coming out about the ethics around the use of virtual reality, because it's very important. And yes, this should always be taken into consideration when a user starts having a virtual reality in his life. and users should always be informed about the impact that virtual reality has on their emotions, on their behavior, and more broadly on their perception. Because of course, we show in research that this has a big impact. So every user should be informed, even if it's for entertainment, about the impact that it has. And yeah, I mean, in some science fiction things, you see like the whole world it becomes a virtual world, and people start meeting only in this virtual world. But even in those fictional things, you always see that the reality is still there, and that they do have to continue to live in the reality. So yes.
So let's talk about your life as a researcher. How did you begin doing research in virtual reality?
So during my master thesis in cognitive science, I did research in about the perception of movies and the impact it would have on the spectator, and I was focused on the difference in perceiving a scene that is filmed in first-person perspective or in third-person perspective, what is called POV in cinema. And so my research was to see if the people would have more higher emotional reaction when they would see a scene from the point of view of the hero. So for instance, the hero is doing something and you will see his hands like this, as if it was your real hands. And this is used a lot in cinema. And I would then put the same scene but filmed from a third-person perspective, so you would see the hero like looking at his hands, but then from outside. And I would compare the emotional reaction of the spectator to that. So this was my interest. And then the director of my research, so in this master's, told me, okay, you should check out virtual reality, because they do this as well. They switch from first-person perspective to third-person perspective. And he oriented me to the lab of Mel Slater, and then I was really interested in continuing this research, and I was really interested in doing a PhD on this topic. And so I contacted Mel Slater, and I had a first appointment with him, and I explained to him my interests, and then he said, okay, so we had interests in common, and yes, we can work together and do this PhD, and this is how it started.
Okay, and so this is how it started. So, of course, you already finished. So, do you have some, given your experience, some helpful suggestions or suggestions for students that are doing the PhD now? They are about to start the PhD. So, what do you would tell them?
So, I think for everyone, it is kind of an adventure, and if I would have one suggestion is to be patient, because we always or at least I've seen many cases where we are always getting stressed that things are not going fast enough, and that we don't get the result we were expecting, and you should. And I was completely like that. So, but I now see when I look at the whole experience from outside, I see that patience is really key in this process. It's a long process. It's like a marathon, and you really have to like continue the process and understand that it is a very complex thing that you are building, and you need to take your time. Take your time and build like one stone after the other, and be rigorous in this building thing, and be patient, because then the result will come. But it will just, because it is such a complex thing, the result cannot come very fast. And patience is a very, very important thing. Patience and rigor in the like and this means like to not get desperate when you get the impression that things are not going as fast as you would want. And yes, because it can be a bit frustrating, but it's really worth it, because you like this is then a real achievement to build something like that is slowly built, but then it's very solid, and then it's also something that you built, and only you could build that. This is the characteristic of a PhD. It is really something that only one person is doing, and this person is becoming specialized in this very specific topic. And this is the magic of the PhD. So always keep this in mind, that this is that you become an expert in this topic, and most of the time it's then only you that focuses on this specific part. And yes, this is what I would suggest.
And so, did you have one or two moments during your PhD that you will never forget?
I will never forget the whole PhD experience. Like, this is way more than 2 moments. There are so many moments that were very, very strong. Emotionally, I learned a lot, and I met a lot of people that are very important friends in my life now, and all this makes like colleagues and friends. This is it's very important also to be well surrounded by the people of your lab, and I had the chance to have this in the lab where I work, like to. So this means that I have that there are many things that I will never forget, because they just they are part of me, of the person I became out of this experience. But so for choosing like only two, I can tell you, like the beginning and the end, these are really the two things that are very important moments in my life, I would say. So this first day that I met Mel Slater and I entered his office, and before entering I had this thrill of, okay, I really want to do a PhD on this topic. Let's see if it works or not. And I did not know if it would work, so I was like very excited and very like a bit afraid, but as well very thrilled, and it was all unknown. Like I had this abstract idea, and I was passionate about it, and when I entered his office, I did not know what to expect, if this would work or not. And then I remember very well the conversation with him, and I remember very well that the discussion was flowing, and we understood each other, and it was like, yes, and then we could do this and we could do that, and there I understood, okay, something is starting here. I do not know how it will be, but here there is something important starting. So this is a sensation that is very vivid still, and that I will never forget. And then second memory is the like after the defense, like when the whole day was over, because it was a long day, And then when I went home, I was like, I don't know, floating. I was like walking on like above the pavement and like walking on the clouds somehow. I don't know. It was really really a very peculiar sensation. So like for for the PhD students that are in the process, like sometimes it can really be hard, and it's a very big challenge, but it's completely worth it. Like the reward you get after the defense and the satisfaction that it gives is really unique, and I never had this sensation before.
Okay, so final question. So assuming that Dr. NEYRET is able to travel in time and can leave a note on a piece of paper to SOLÈNE when she has a master's degree and she's about to start a PhD. So two things. What do you write to yourself from the past, and will yourself from the past follow the advice?
This is a hard question.
Of course, not something like invest in this company, something like related to the PhD.
No, of course. I think I would write an advice that that I received during the PhD from a very important person in my life. That is keep your eyes on the road and your hands upon the wheel. You know, it's the song by the Doors. Like, really stay focused on the road, and it will come out. And like I would write on this piece of paper, even if you get desperate, don't forget about where you're going. And also, I would advise to myself and to any PhD student, make a list of the reasons of why you started this PhD, because there will be good reasons and there will be bad reasons. Of course, we make decisions like based on many influences that we have around us, like social influences and influences of our own like motivations and everything. So make a list of all the reasons, and then during the process, always go back to this list and choose which reasons are good and worth it, and then focus on that. Okay, I'm doing this because of this, that, and I want to understand better this topic, and I want to develop my knowledge around this, and I want to get a PhD because this is an academic achievement and this is important for me. And I mean, everyone has their own reasons. And so I would advise myself to, when I don't know anymore why I'm doing that, to go back to this list and remember it. And yes, and stay focused on the road and stay focused on the pathway, because it's very nice. It's a very nice ride if you stay focused on like you will not see the end of it. Like when you're driving, you don't see the end of the road at all, but you know that you're driving and you should enjoy the ride.
Okay, great. So we thank Dr. NEYRET to be here with us today, and thank you very much for your time. That it was really interesting, also, especially also the topic is really interesting, and you also answered very interesting to everything. So merci beaucoup for this interview.
Merci à vous. Thank you very much for inviting me. It was a pleasure to share this moment with you.
Okay,
and good luck for the PhD, and keep hope. This is very important.
Okay, thank you very much. Bye.
Bye.
Okay, this was the second day of the PhD event, and thank you for listening us. We hope that everything was helpful and insightful for you as it was for us. And have a nice evening, and see you next time.
Bye-bye.
Bye.
Bye.
Bye.